Have you ever wondered who actually makes the processors that power, well, everything? Today we're talking about a company most people have never heard of, but one that quietly became the single most important company in all of tech. This is the story of how TSMC secretly won the chip war.
So let's just dive right in. How does one company, pretty much operating in the shadows, become the manufacturing heart of the entire global tech industry? I mean, that's an incredible position to be in. It's really a fascinating story of strategy, incredible foresight, and some really big bets.
Just think about it for a second. The chip inside your iPhone, the super powerful GPU that's driving all this cutting-edge AI, the little brains inside your car, they all have to be physically made somewhere. So who is it? Who has this near monopoly on manufacturing the world's most advanced silicon? Now, your first guess might be a company like Intel, right? Or maybe Samsung. But the real answer is a company that, for most people, just completely flies under the radar. Yep, that's them, TSMC. They are the undisputed kings of making semiconductors, and their journey to the top is just a masterclass in business strategy. And it all started with a deceptively simple idea. You see, the first really big piece of this puzzle wasn't about making the chip itself faster or more powerful. No, it was about how you wrap it up. It sounds almost trivial, right? But this one move was the key that unlocked absolutely everything else for them. The technology is called InFO, that's INFO, for integrated fan-out. Now, the core idea is actually pretty straightforward. It's a way to package a chip that essentially gets rid of an entire bulky layer, making the final product smaller, more power efficient, and way better at handling heat. And here's why that is such a huge deal. Think about a company like Apple. They are completely obsessed with making their iPhones thinner and more powerful every single year. So for them, this wasn't just some small improvement, it was a total game changer. A thinner chip package means more precious space inside the phone for, say, a bigger battery. And here is the crucial point. Back in 2016, this unique packaging technology was the single reason Apple gave TSMC the entire contract for the A10 chip that went into the iPhone 7. This exclusive deal was the first domino to fall, and it sent absolute shockwaves of cash flowing straight into TSMC's bank accounts. Okay, so with Apple's business and all that money locked down, TSMC turned its attention to the next phase of its master plan. Buying a piece of equipment so rare, so expensive, and so powerful that it basically acts as the gatekeeper for the entire future of technology. It's called an EUV machine, which stands for extreme ultraviolet lithography. You see, as chips get smaller and smaller, you need a brand new kind of light to draw the impossibly tiny circuits on them. EUV is that light. If you want to make the most advanced chips in the world today, anything below 7 nanometers, you absolutely have to have one of these machines. There is no other way. And that is not an exaggeration. The source material for this actually calls it the magic wand of the industry, and you can see why. It's the one tool that lets these companies perform what is basically modern magic, cramming billions and billions of transistors onto a tiny sliver of silicon. But you know, magic like this does not come cheap. Each one of these machines costs over $200 million. It weighs as much as an Airbus A320 jet, and there's only one company on the entire planet that can make them, a Dutch company called ASML. So now we have the two key pieces on the board, the clever packaging technology that won them the Apple deal, and this hyper-expensive magic wand machine that you need for the future. And this, right here, is where TSMC's genius strategy really clicks into place. They use the money from the first piece to pay for the second. This timeline really shows you how it all connects. See, in 2016, they lock in that massive, steady stream of revenue from Apple. Then, just 2 years later, they become the very first company in the world to use those crazy expensive EUV machines in mass production. That was not a coincidence. This is the brilliant virtuous cycle they created. The money from millions of iPhones directly funded the purchase of the world's most advanced and most scarce manufacturing equipment. By buying up ASML's very limited supply, they not only got ahead, they made it physically harder for anyone else to even try to catch up. And once they mastered that next-gen process, well, every other company demanding the absolute best chips, like NVIDIA for their world-changing AI GPUs, had no choice but to knock on TSMC's door. But that brings up one last, really important question. I mean, other companies have tons of money. Why was TSMC able to pull this off so perfectly when its huge rivals, like Samsung, just couldn't?
Well, it really comes down to three core advantages. First, they were super early partners with ASML on R&D, helping to develop the very technology they would later buy. Second, they got priceless, real-world data by being the first to use EUV at a massive scale. But honestly, the most important advantage of all is their business model. And this table just perfectly illustrates the difference. TSMC is what's called a pure-play foundry. All that means is that their only business is making chips for other companies. They don't make their own TSMC-branded phones or graphics cards. This means their customers, people like Apple and NVIDIA, trust them completely. They never have to worry that TSMC is secretly learning their designs to become a competitor. This absolute focus builds a level of trust that other integrated companies just can't match.
So when you put it all together, you realize this wasn't about luck. It was this incredible combination of smart technology like InFO, incredibly bold financial bets on EUV, and a foundational business model that's built entirely on trust. Together, that blueprint allowed TSMC to build a lead that, today, seems almost impossible for anyone to overcome. They executed this flawless strategy and became the undisputed king of the world's most critical industry. But it leaves all of us with one final and kind of unsettling question. What are the risks when the digital foundation of our entire modern world rests in the hands of a single company on a single island?